How does the human brain build itself? How do circuits in the human brain wire together? For instance, how does one tiny neuron in the outer layer of the brain send a thin axon all the way to the spinal cord, find the right neuron, and then control muscle contraction as we extend a hand and grasp a glass of water? I'm here to tell you that we can finally grow parts of the human brain from any individual and then build functioning human circuits in a laboratory cell culture dish. These clumps of neural tissue are known as brain organoids. And when we put them together to form circuits, they become assembloids. Assembloids could be key to understanding how the human brain is built. Today, most of what we know about the human brain comes from studies in animals, typically mice. And while we've learned a lot from these animal brains, the characteristics that make the human brain unique and uniquely susceptible to disease remain mysterious. I'm a physician by training and professor at Stanford, where my laboratory has been taking unconventional approaches to study how the human brain develops, how disorders in the human brain arise, and find new ways of treatments. I think the best way to explain, though, how we do this is through the eyes of one of my patients. When I opened my lab at Stanford, Edward, who's on the autism spectrum, sent me this drawing depicting how he thought we were studying brain disorders. Now, to paraphrase him, he said, "What I think you're doing is you're climbing up a ladder, poking holes in people's brains, and then use tiny telescopes to watch neural cells." Of course, that's not what we do. So I called him up, explained the process, and then next morning, he sent me another drawing, which I think ended up being a quite accurate representation of the work that we and many others now are doing. Again, to paraphrase him, he said, "You're taking skin cells from patients that have specific brain disorders, then doing some mumbo-jumbo to the cells to push them back in time and turn them into stem cells. And then he knew that stem cells can be coaxed to become any cell type. So then you're taking them and turning them into brain cells that form brain circuits." That's right. We can build human brain circuits in a dish. How is that possible? Building on the hard work of biologists over the past 15 years or so, we can today take any cell type from any individual and then push it back in time to turn them into stem cells and then guide those stem cells to become any other cell type. We start by asking a patient to provide a small skin sample. We then take those skin